Hello everyone, my name's Adam and welcome back to the channel. Today we're taking a look at this, my print server. It's basically a Raspberry Pi with a screen that can control multiple printers at once, upload firmware directly to those printers. It can take time lapses during the printing and do all the other sort of typical management stuff you expect from something like this. In this video we're going to be taking a look at the software that used to do this, the hardware that I've used, and some instructions on how you can build one yourself. Let's start by taking a look at the software. So back in 2016 I had my first 3D printer, a Syntron i3, which I don't recommend by the way, and I used Octoprint on a Raspberry Pi to control it. I mean, I didn't really need to, quite honestly. It was literally sort of this far away. I could turn around and touch it. So that whole management thing was a little bit unnecessary, but I wanted it to be able to take time lapses. However, as time moved on, I designed Steve, my custom Core XY 3D printer, and then I had 2 printers which I wanted to control. I didn't really want to buy another Raspberry Pi, so I looked at other software that could kind of control multiples at the same time. I did come across the fact that Octoprint could potentially do it. It requires a bit of higgery-jiggery, but there's nothing sort of baked in that allows easy setup for that. And that's when I came across Repetier Server rather. Repetier Server is like Octoprint in many ways. It does all the typical sort of printer management stuff that you'd expect from something like this. It controls the movement, can do the homing, turn off the motors, all the heating and graphs and all that sort of stuff. That's all just general functionality which you have in Repetier and in Octoprint. However, Repetier does have 3 specific features which I have really enjoyed using and I think are the main reasons for getting Repetier Server over Octoprint. And those are 1. Easy use of multiple 3D printers. So one Raspberry Pi can plug into 2, 3, 4 printers and control all of those all at the same time. That's pretty useful. So in my use case, I had Steve and my i3, and I could then control both of those off one single Raspberry Pi. Brilliant. The next thing is the easy firmware uploading. While designing Steve, I was going through a whole load of firmware iterations, kept writing again and again and again and again. And to do that, because the computer was across the other side of the room from the printer, I had to have this really long USB cable and a powered hub in the middle because it didn't have enough power to go all the way. And all this sort of, it was just so much kind of annoyance to have a USB cable all the way across the room to do that. So that's the point when I ended up paying for the full version of Repetier Server, and that allowed me to do the firmware uploading directly to a printer. So from any computer on the network, you can upload firmware, it drives it straight into the control board, sets the new firmware. That is an absolutely brilliant feature if you're continuously writing firmware, such as you might be when designing a 3D printer. The third great thing about Repetier Server is that in my use case, it seems to be a lot faster. It's kind of lightweight. It seems to use fewer of the Raspberry Pi resources and is able to run really quick. It boots up really quick, kind of does all the features really quickly. I've never done any slicing, so I couldn't test that. I imagine that's fairly similar, but that kind of lightweight software just makes things more enjoyable to use for me. So yes, those are the 3 things I think are the best about Repetier Server. However, of course, Octoprint is still a fantastic software. I'm not saying you should definitely use Repetier Server and ignore Octoprint. Definitely not. There are 3 main things, again, that I would choose Octoprint for over Repetier Server. Firstly, Octoprint is free. You don't need to pay anything for it. You get all the features without paying anything. Like, that's a no-brainer in my mind, especially if it's your first printer. You already have a Raspberry Pi and you just want to kind of test some things, see how you like it. Octoprint is a great way to do that because you don't need to spend any more money. It's also, of course, open source, which means all the code is available. You can make your own modifications, and that all comes into the add-ins. That's another great feature of Octoprint. There are add-ins available, so people can write add-ins or plugins, whatever you want to call them. Are they the same? I'm assuming they're the same. I don't know enough about coding to know the difference. So anyone can basically write any sort of add-in piece of software to increase the functionality of Octoprint. The last thing about Octoprint that I think is really great is the time lapses. This is kind of a result of being open source and having the add-ins. There's an excellent plugin for time lapses. So if you're really keen on doing amazing time lapses, which as someone who creates YouTube videos, I probably should be doing, but I still quite like Repetier Server. Anyway, it does this fantastic thing where it moves the head to the side and takes a print. You need to go and see Octolapse time lapses because they look brilliant. So that's pretty much it for all the kind of software side. If you want a kind of live demo of the features of the touchscreen and the web interface, then you can go over to the Repetier website and they have a live demo. You just click the button and it starts up the interface, and then you can click around and try all the things and look at the things and the buttons and all of that stuff. All online, don't need to pay anything to have a go. Obviously you can't connect that to a printer, it's just online as a demo, but it's kind of, it gives you a good feel for how usable it is, what the features are, and how you can access stuff. Now that that's all covered, let's have a look at the hardware. There are basically three main things here: the screen, the control board, and the printed parts. So we have a Raspberry Pi Model 3. The reason I chose that is because it was the best available at the time. Now there's a Model 3B Plus and the Model 3A, I think it's called, which is like slightly smaller. I mean, I'm sure that screen is very compatible across the Raspberry Pis, and the screen is the official Raspberry Pi touchscreen. So compatibility should be pretty much a no-brainer. It's very easy to install and set up. The reason I chose it is just because I thought having a screen would be cool. I mean, there was not really a whole lot more thought behind it. The printed parts are basically there to hold the whole lot together, stop you prodding and poking fingers and catching wires and all that sort of stuff. It also means that you have these nice arms at the top which allow you to mount it kind of in all sorts of places. These brackets are easily adjustable, easy to remove. So yeah, that's pretty much the printed parts. In some respects, I was kind of right. The touchscreen is pretty cool, but the use case is fairly limited from my use case, if you see what I mean. So a bit like we have here, the Raspberry Pi is attached to the printer via a USB cable. And as a result of that, the distance between these two things is fairly limited. That means if you're going to access the touchscreen, you'll also probably be very close to the printer. Do you see where I'm going with this? If you can use this screen to control the printer, you could just use that screen to control the printer. However, there are of course circumstances where you can have a printer without the touchscreen, control screen. That's not necessarily required for a 3D printer, I'm pretty sure. So you could just have this instead and multiple printers, and the printer is then kind of headless, if you like. The other thing that's not so great about the interface is the color scheme and the usability. As you can see from this, there's quite a lot of things to press. I mean, you're going over here and then all the buttons are really, really spread out. I feel like if these buttons were a bit closer together, then you could do maybe all of this stuff and all the extrusion stuff on the same page. It's like, I don't need to click around here and then go here and then go here and then go there to do all this stuff if it was kind of maybe bunched into the screen a little bit more, because as long as it's big enough to kind of touch easily, you don't need much space between them. Also, the Raspberry Pi touchscreen is not that great for kind of scrolling anything. It requires a bit of, it's not quite as good as a phone screen. You know, they've been designed and they're all kind of slick so you can slide and whatnot across them. The material used on this glass is not quite as good at that, so you get a kind of skip. So it's kind of just a minor usability thing really, and it's not obviously directly related to use of Repetier Server at all, but it's just something to be aware of. It's not super slick like you might think it could be. I've already done a focus video on the 3D printed parts as part of my 3D TWIP series, where this week I 3D printed and talked you through the parts and the materials and all that sort of stuff. So if you want to see those, I'll leave a link in the description and in a card up in the corner if I remember. So what do you need to do in order to make one? Well, you're going to need a Raspberry Pi. I've used a Model 3, but others will work. A Raspberry Pi official 7-inch touchscreen, a 5-volt USB power supply to power the screen and Pi together that can do approximately 3 amps output, a micro SD card for the Raspberry Pi, a computer with an SD card reader or kind of separately so you can set up the Pi using the computer, the printed parts for the final assembly, 4 M3x8 screws again for the final assembly, and some additional screws for securing the whole unit onto a shelf or whatever you want to put it. The steps you need to go through are as follows. 1. Download the image from the Repetier site. Make sure you get the latest version of the Raspberry Pi image. Unzip what you've downloaded and identify the image file. You don't need to do anything with it just yet. Second, you want to download Etcher or your chosen software for writing images to SD cards. Install it. 3. Use Etcher to write the image you downloaded to the micro SD card. 4. While the image is writing, set up the Raspberry Pi. Plug the screen into the Pi according to the instructions for the touchscreen. It's quite simple and it doesn't take very long, but while the image is going, you might as well do that. 5. Once the Raspberry Pi is set up and the image is written, plug the SD card into the Raspberry Pi and power it up. 6. Repetier Server should boot up. 7. Connect your Raspberry Pi to your network using Ethernet or browse through the menus on the Raspberry Pi touchscreen to connect over Wi-Fi. There are headless options available if you want to do this without a screen. Go and check on the Repetier Server website of how to do that. It's not too difficult, but I'm not going to explain it all here. 8. Enable the license if you bought one to get the full functionality. 9. From there, you're pretty much ready to go. You can knock yourself out. You can go set up all your printers, materials, profiles, custom G-codes that trigger at certain times and all this sort of fancy stuff. The world is your oyster. If you need more assistance on how to do the setup after you've got it kind of working, to do with printers and all that sort of stuff, then head over to the Repetier website and you can find lots of information there. So that's it from me today on my 3D printing server. We've gone over the Repetier Server software that allows me to control multiple printers at the same time, upload firmware to those printers and do all sorts of other great stuff. We've got the Raspberry Pi and the touchscreen that basically is the center of the whole thing, and the 3D printed parts which I've covered in a separate video. Of course, I've also given you the instruction of how you're going to make one yourself, which will be great. All the 3D printed parts, of course, link in the video description. Like and subscribe if you want to see more from me. Follow me on Twitter and Instagram, so all the behind the scenes kind of stuff and see what I'm working on. Join me on Patreon if you want to support the channel and get some other great benefits. Thank you very much for watching, and I will see you in the next one.